Hi, in this video we are going to see how we can fine-tune Llama 3 model for better instruction following. So basically there are multiple steps if you want to fine-tune an LLM Llama model. So first is configuration of the model. First we have to do like all the configuration, importing and everything. Then we have to load the model, and then in this video we'll see before fine-tuning what kind of output we are getting, and we'll then fine-tune the model, and after fine-tuning we'll see what kind of sample we are getting after fine tuning, and then we will save the trained model to Hugging Face. So in this readme file I have mentioned some commands which will be required to set up the Jupyter notebook for the training purpose. And so these are the following commands. First of all, we'll be creating a conda environment with Python 3.10. Then we'll activate the conda environment and install the dependencies. So in this case we can see we are installing PyTorch with CUDA 12.1. We are installing Unsloth library. We are also installing WandB for our monitoring and logging purpose, and then we are exporting the Hugging Face token so that it can be used to save the model, and also we are installing this fine-tune Llama and Sloth library. So these are the dependencies before starting the fine-tuning process. And here is a Jupyter notebook that we can see. So before going into this Jupyter notebook, I would like to show you like currently what are my system configuration which is like required to train this Llama model. So if I do NVIDIA SMI command, so currently like we can see the CUDA version is 12.4, NVIDIA driver version is 550.54, and we have 80 gigs of memory available. So right now the GPU which I have is A100G. So that is like one of the best GPUs which is generally used to train these Llama models. Okay, so let's get started. So I've already exported the Hugging Face token, but I have like hidden it for now. Then after that we'll be importing some libraries, and this is the URL for the dataset on which we'll be fine-tuning the LLM model. So just to show you what this dataset is. So here is this Hugging Face URL which I have opened, which talks about the dataset. So here it is it is a dataset about like how a chatbot performs with different examples. So maybe we can see one example. So first is like write me an article about Chess immigration World War I discussing following, and then we can see in response the bot is answering to the query which human has asked for. So basically this data set contains all these information about a query by a human and the answer by bot, and the model that we are using, so it is not trained or it is not instruction fine-tuned to perform in this way. So using this data we are going to fine-tune that model so that it can perform in a specific behavior. So that was about the dataset. In this case we have downloaded the dataset, and we are then going to use it for training and testing, and we have also done a training split. After that we are going to load a Llama 3 model. So this Llama 3 model generally takes up a lot of GPU requirement and everything, but in case of Unsloth we are using a optimized version of Llama 3 so that it can be fine-tuned. So we can also search for this on Google so that we can get a better information about like how this Unsloth library works and what kind of model it has. So we can see here it is directly quantized 4-bit model with bits and bytes. So when we do quantization, it is like easier for any model to fit in the GPU memory and get trained. And this Unsloth company also has given out multiple different notebooks and different models which are supported to basically fine-tune. Also let me also show you what Unsloth library is. So here we can see Unsloth GitHub page. So as we can see, Unsloth is an open source library which is designed to significantly accelerate the fine tuning process of these LLM models. And there are like some key features and benefits of this Unsloth library which you guys can read about. Going back to our notebook, so here we have like loaded up the pre-trained model from Unsloth and also the tokenizer, and also we can see here some kind of output. Here it is showing me what kind of GPU I am using, what max memory we have, and also the PyTorch and CUDA versions. After that, I have generated a response based on the pre-trained model, which is not currently trained on the dataset we have downloaded. And for this case, list top 5 popular movies of all time. We can see what kind of output it is giving. So here it is just auto completing it. What are the best all-time movie? It gives one, and again the bot asks. So this is not the particular behavior which we are expecting out from this LLM model. So now we are going to fine tune this model for giving the output in expected form. So this is the model training part. So first what we are doing, we are loading up the model, or like we are now what we are going to do, we are going to patch the big LLM model with a small model that we are going to create, and then we are going to merge it. So this way we are defining the model for doing the patching, and also using fast LoRa weights for that. So these are the configuration, and then we can see in SFT trainer we have like loaded up this model and given the different training arguments and maximum sequence length and the tokenizer to start the training process. So now I am going to start this training process. So now let's see how much time this would require to complete the training process. And also just to show you the training split that we have, it has around 2,10,289 samples. So that's the dataset size which we are training on. So like more is the dataset size, the more GPU RAM it would require based on the batch size. And also it depends on like how many number of parameter a model has. So in our case, since we are training Llama 3 8 billion model, so it has like 8 billion parameters inside it which are going to be trained. So we are seeing the training process has already been started. We could also see how much RAM it is utilizing using NVIDIA SMI command. So currently it is using around 6 GBs of memory out of 80 GBs, and 51 of the GPU utilization. Not much. So now it is going to take around 35 seconds to complete the training process. So let's wait for that. So it is also showing that we can see the training logs on won't.be. We can also see the learning rate is going down, training is increasing, and loss is not going down gradually, but yeah. Looks like the training process has now been completed. So here we can see like how many number of parameters got trained, which is 41 million. Batch size 8. Okay, now since the training process is now completed, let's see what kind of output it generates. Okay, now as we can see, it has generated output, and now it is not altering between human and bot output. In just one single response, it is able to give all 5 movies according to the response that we expected. Now it is time to like save the model on Hugging Face, so that anytime in future we can use this model again just by downloading it and not training it again. This command will merge the trained model with the original model and then upload it to the Hugging Face. So this is the merged model, and it is the unmerged model that we are going to save to the Hugging Face. So this output folder is generally the place where the model gets saved, and it is being then picked by the upload function and then uploaded to the Hugging Face. Let's wait for the complete process to be completed. Here we can see the model has now been uploaded to the Hugging Face. It is still taking time to upload all the tensors and all. So till then all the steps are being completed, so we can conclude this video. So in this video what we have seen, first we have like set up the Conda environment, then we have opened our Jupyter notebook where we have specified the data which needs to be downloaded. We have split it into the training and testing dataset. Then we have configured the model and tokenizer, and then before training we have generated an output of the pre-trained model, and then we have done the training by using the patching method and also the fast LoRa. And once the training is done, we have generated a sample output to see how the model performs, and then we are uploading the trained model to the Hugging Face. So that was about this model. I will be uploading the repository, GitHub repository, where I have put all the model files and everything. So please check them if you would like to get this code. Thank you.